Right, we've got a realistic 1007 here. We've got two. One's mine, one's a customer's. This one's a customer's. This is a set you can't do without the service manual. Certainly can't do the transmitted audio without a service manual. It is a beast to set up the transmitted audio. And these and Binatone Route 66 mobile sets always sound the same, the way they have a voice peak and then the AGC comes in. So I think the customer thinks this may have been wet. So I think we'll start by opening it up. Now we don't ever test hand portables on batteries, and as a trade supplier we expect people with battery problems to be able to sort them out. We'll sort the electronics out, but not battery compartment problems. People who are end users and need battery problems sorting out can still send stuff in, but we'd have to work out some tariff. Right, we'll put the soldering iron on because chances are we're going to need it. He also said one of the screws he's rounded off may need drilling out, which is quite possibly true. If you're going to get water in these, it's going to collect in the bottom. And we've had quite a few of these, which is nothing we can do with them because of ingress of moisture. Probably more than any other hand portable. Yeah, I think he's absolutely right there. See what wrong screwdriver will make it work. The technique as an organ builder is to try and tighten a screw, and that will break the seal, and that's happened here. So you can see how corroded that is, but I've got it out. I'll probably cut a slot in there so we can actually put it back with a slotted screwdriver. I'm not going to be able to replace that. Unless, of course, we've got a scrap AM set, which we may well have. So when we open it up, it isn't too scary. There's a little bit of moisture around the face like loop chip, and round the PTT bar. Let's have a look at the other side. I've seen much worse than this. So is this corrosion or is this paint? I think that's corrosion, folks. I'm going to take this board to Mr. Chippy's room. Anyway, it's only the display. Who's bothered about the display? I'll go and deal with that. Okay, so I've had the isopropyl alcohol on those connectors, and there's another connector here which I've also dealt with. And can we unfold that at the same time? Just about. This will need to come off again. There's a dry joint there. The double-sided boards, they do suffer from dry joints. They're plastic cased. They haven't got the range boost side panels like the 1005 and the 1007 have, and they're not the range of the 1005 and the 1007. So if you're expecting to get 14 miles, you won't. Pop that back for now. I didn't clean that one with the fiberglass brush. That looks like it's in. Right, that brings us to getting some power on it. So, amongst the tat on here, there should be a power lead. Put that into the power socket. Connect that. These are a 12 volt radio. Check it with the service manual. I'll do the other one in about 5 days' time. I don't want to do two consecutive, the same set. I get enough moans and groans when I do yet another Cybernet, but they have different faults, don't they? Not just a straightforward tune-up. Originally, we were only going to do one type of each set, you know, so we're going to do one Cybernet 134 and one, but people have wanted me to do the same things time and time again because they're different. So, 12 volts. I'm current limited. I wanted to make sure it was powering up. They boot up on channel 9 just to annoy you. And it makes the right kind of hiss, which is great. Let's see what the service manual says about the voltage. You'll notice they're a 3.5 watt set, and they want you to be able to get 3 watts out of it. They also want you to have a 1 microvolt sensitivity, but it's difficult to read anything because you're on the inherently lossy RCA socket there. The only thing we could do better is actually to make up a lead. Our test set is N-type. We could make up a lead N-type to a gold-plated phono plug just to get that little bit of thing. In fact, I ought to order the parts in, but at the end of the day, that's like 20 quid worth of parts, isn't it? To come out of my poultry church wages. Power. £12.5 volts, plus or minus 15%. So with the pink calculator, 12.5 times 15% plus equals, it will do 13.8. So there you go. That's nice to know, isn't it? So that's what it says. I'm going to do I'm going to do what I can on 12.8 volts, and then we'll do the power test at the end when it's all tuned up. We'll do that on 13.8. That's great news. So channel 20. It's just a rotary encoder. It's not a real channel selector switch. It's just a rotary up-down. So I need to connect our adapter so an SO239 to Motorola adapter. So the fact it's long goes into the old-fashioned kind of car radio sockets. That's a Motorola connector, but it also is the same but a little bit longer reach than a phono. So we're introducing loss. This is in quite a good condition because they go hard and brittle, so I'll put that to one side. Right, we're connected up. Let's put picture in picture on. Which button's that then? It's that one. Oh, it's appeared. There we go. So I'll press transmit. Good. Well, I'm in the 3 watt scale and we're on low power. So we'll switch it to high power, which says 4 watts high. Well, it isn't. It's a 3.5 watt set. So that it's the old 3.5 round it up, or 3.4 you round it down. And right now it's doing 2 watts. So we'll see how well balanced this is. 2 watts. Channel 1. 2 watts. It's excellent. Right, back to channel 20. Let's look at the current consumption, 706 milliamps. You want it to be low on a handheld, don't you? And on low power, the radio's doing 110 milliwatts. I don't think that is enough. So, as we are at the moment, it's under. Oh, it's acceptable on the low power. Who would have thought that? So good. Quick deviation check. See whether this test set's behaving today, or whether we'll move across to the other one. Voila! It says it's 2 kilohertz. And the frequency, go to the frequency counter so you can see that. And we've got 2779112. It's spot on, isn't it? You could say that was spot on. Right, we'll look at receive. If I plug the equipment into the extension speaker socket, we'll set the signal generator for 2779112. As ever, I haven't got time. I think I've got 10 minutes between the next thing. Got a funeral to do tomorrow, so I don't know what we'll cram in as well. A shopping trip for an elderly lady, who I'd always do on a Thursday, and a funeral as well. Purely as an organist, nobody I know from Adam. Right, let's see what we can hear. not a lot. So at the moment we're getting 1.6 microvolts. Just see whether holding the connector makes any improvement. A little tiny bit. So we look at that again. Still 1.6. For 10 dBs it is 1.3. I don't want you to think it is deaf though. It's because of the lossy. Arrangement. For 20 it does actually do it. It's 8 microvolts. And again, for true reading you need to disconnect the rod antenna, you'd need to disconnect the loading coil, so it's not straightforward. But at least we can align it. Squelch at the moment is 27 microvolts tight, and full sensitivity, set threshold, 2.6 microvolts. I'd like to improve that certainly to less than 1.5 if possible, but it just depends. You know, you can tell the difference. They don't have a meter. Good. Well, I went through that list. Right, we will see. Let's turn the volume down. Let's see what we need to do to sort out the transmit. Very good service plans, realistic ones always are. For those of you interested in how phase-lock loop systems work, there's a detailed description of how they work. And it's a C12101. I think that's the same as the Baby Midlands, isn't it? These were made for them by GRE in Japan, unless it says otherwise on the back. It's Japan, so it's GRE, General Research Electronics. They even did a Trio receiver for Trio back in the late 60s. Trio couldn't be bothered to make a particular model, so GRE made it for them. So let's have a look. Oh, troubleshooting. So I don't know what faults this has had, but I've probably sorted whatever was out was dodgy with it by doing what I did with the isopropyl alcohol. So they want you to check at channel 1 the test point. This is your VCO. They want to check at test point 3. I think we have to take the display board out. Yeah, no. Yeah, no. Test point 3. Just pop the power off, because like the other realistics, it's under the screen. and they've got a handy little bit of lead specially poking up in uninsulated to make this test. This is where you've got the quality, isn't it? No, Mr. Tango, I think they're rubbish. Right. We want to try some other makes then. Right, so we should have, when I put the power back on channel 1, that's not good, is it? Oh, test point 3 could well be that, which is also uninsulated. It's more like it, isn't it? And when we change channel, yeah, that's it. So we've got 1.7. See whether that will hold on that test point. It's not the diode looking thing, it's the resistor looking thing. There we go, 1.5. I'll go to channel 40. Doesn't mention this in the book, but that it looks like the correct position. Let's press transmit. Doesn't mention that in the book, but it looks right. Yep, we'll go with that. So that's adjusted the VCO. So back to the diagram. I initially thought it was the diode there, with its lead all nice and shiny, but test point 3 is actually the resistor there. Bet you're glad I paid £16.99 for this service manual at the time from Tandy's. Now they want you to test the frequency at test point 5, but we're not going to do it that way. We're going to do it with the frequency counter as we have already on the display. So 2760125, and it is where? It's TC1. I've got to find TC1. TC1. I think it's under the display board. It is under the display board. So is it possible for me to select channel 20 and then take the board out? It is. See, it's still on channel 20. Do not put the board back with the power on. I'm going to leave it at that. (27.79124). VCO was 1.3 volts. It's now 1.5 volts. So switching the power off, we'll put the display board back. And of course it'll boot up on channel 9 to annoy you. Right, we'll move on to the next section. So it's L3, T7, T8, T9, L5, L6. So let's find the layout. Should be so straightforward. So here's the layout. So we started with, let's just get this right, L3, T7, T8, T9. L3 is there, so we will peak that right now. Let's go to the main meter on the test set, go to full power, and we're at 12.8 volts. The centre of so that is now a centre. We need to be doing VR3. It doesn't say do that first, but we do. This is the power set. Because if we try and tune it up with the power not set to full, that can cause some shenanigans. So power at full is 2.3. So the next one is T7, T8 and T9. T7, T8, T9. T7, T8, they were all spot on. And then L5 and L6. That's L6, that's L5. It's not actually happy. That one. So it's doing 2.5 watts. Just check our connector. I'm not sure what's making it go off. Right, we're going to bump the power supply up to 13.8 volts. And just check the band edges. Something is making this go off. .8. That's not happy bunny noises. We'll just adjust that again. Check channel 1. Check channel 40. So it's 2.8 watts at the moment with the set hot. So we'll come back to that. And remember, this is lossy, so it is doing better than this. So we now need to check that low power, which isn't adjustable, is within the limits they've set. So I don't need to bother waiting for it to cool down because it was already within the limits. Let's get a reading. It's now 12.6. Let's try that again. I'd like to say it's 2.8. So 0.28. So put that down. 0.28. 280 milliwatts. And on full power, our transmit current is now 820 milliamps. Check that's within what they want. It is. They'd like it to be 700 milliamps, but the limit's at 1000, so we're all right. I'm tempted to put the screen cover back on so that if there's any VCO not locking shenanigans, we'll catch it with the screen plate on. Anyone know where I put the screen plate? On its side somehow. I think the negative battery pole's touching the aerial sometimes, so we'll just put it like that instead. Okay, now we'll come to the complicated bit. Pre-adjust variable resistor 2 for 2.5 volts at test point 6. This is transmitted audio. Now I'm going to come back to that because I need different test equipment. I might be able to get away with it, having said that. So test point 6. Isn't clear where it is. Look at the layout. Always struggle with this. So it looks to be resistor 79. So we've got the filter, the chip with the capacitor on top of it, then the third part along one, two, three. That should be the test point. See whether we can get a reading. What are they wanting? Right, so with our little oscillator, stop that, is test point 6 where I think it is. I'll pause the video and we'll talk about it. So in fact, when we look at the circuit diagram, test point 6 goes to VR2. So it goes to all these components, including the field effect transistor there. Goes so we can measure it at any of these points, and that includes VR2, one leg of it. And see if we can get to that. I think that's what we'll do. And when we actually probe it, so we're in receive, now we're in transmit, and with a tone, we've got 2.5 volts. Let's take the tone off. What we're supposed to have. It is 2.5 volts, so that is exactly as it should be. So we're not going to touch VR2 because it's set up right. You then adjust VR1, which is the deviation. So you then go back to VR2. So it's a 1 kilocycle deviation. With that preset, and then bring it up to the required deviation, which I say is 1.8, but we want 2.2 with the preset 2. So 1 kilohertz deviation with 1, and bringing it up to the required deviation with preset 2. So we will go over to our other signal generator, and then we'll have to take that break. You can see what a faff it is setting these up. So here's the fun bit. Could use an external mic, couldn't I? That would make it easier. But we'll walk across between the two benches. Wallow. And at that it's just bring that up a fraction on there. Wallow. That's where we are. Right, we'll do the receive when I come back. Right, so now we'll move back onto the receiver. In actual fact, we'll take the power readings now. 2.9 watts. And 2.85 watts. Right, just do the receive. Make sure the signal generator is on frequency. So we had it slightly low before, with the radio being slightly low. There we go. Plug it into the thingy. And we want to start with the detector. Don't know what the manual says, so we'll see what the manual says. Transformer 4. There's a harmonic trap here, which we're not going to touch. To do with the spectrum analyzer, if you wanted to, if you felt, or if that had been fiddled with. No need to do that here. We're looking for transformer 4. So it's that one there. So an S9 signal on, we'll put the oscilloscope on, switch over to the oscilloscope. Maximum recovered audio. It was already spot on. So over to the cyanide meter. About 4 dB on there, so we can see what we're doing. Transformer 1, 2, 3 and 6. One, 2, 3, 6. One, 2, 3, 6. Absolutely no difference at all that I can see. Right, we'll have a look at what the signal generator makes of it. Once again, I'll hold on onto the 1.6, that's not changed. 10. 1.3, the same. And 8, exactly the same. So it was absolutely spot on. There's no squelch adjustment, so the squelch we had before is what we got. But just to prove it, squelch to full. It's now 60 microvolts. Actually, I'll hold on to the set. It's 44. And sensitive end. I'm going to knock the signal generator off frequency. Right, sensitive end, turn the squelch down. Threshold, signal generator to standby. It's 1.7. 1.65. But as I said earlier, this is all because we can't get a proper connection ever. When we put this on the aerial, it's going to be a little bit less lossy, and when it's on its own telescopic aerial, it won't be lossy at all. I could just test this with a external mic, but we'll do that on the air test. It's not being presented with an external mic, so I won't go into it. So that's it. So the big snag is setting variable resistor 2 for that 1.5 volts with the test point, which is a bit vague, and then setting 1 kilohertz deviation and topping it up with that adjustment. It's all a bit messy abouty. So there we go, that should work fine. So we'll put it together. I think the only moisture problem there was what I dealt with. It certainly hasn't played up. You see some surface rust just there, but it's only the framework of the PCT bar. You know, somebody's used this out in the damp, haven't they? I can actually see a bit. I can actually see. So I'll just turn the power off. I can see something under this telescopic aerial. Yeah, I want to get rid of that. So I'll go over to Mr. Chippy's bench and deal with that. And while I'm at it, I'll go across to our organ workshop and I'll run a hacksaw through that to give us a groove. On second thought, if changing my mind as I go here, I'll see if we've got a scrap AM one. Okay, so I've done that. When I took the rod antenna out, I also saw there was a little bit of corrosion on the channel selector switch. No, that's not the on-off volume. So dealt with that at the same time. There's a little bit there, dealt with that. Gone over that. Done down there. So can't see we've got anything left. And I did go into the shed and I did spot an illegal AM one. So we've now got the aerial off that. Right, so we need to make sure that we've got the rubber covers there. Need to make sure we've got the rubber covers there. Check that the rod antenna screws tight. So the long screw. The good condition existing screw. And my one out of a scrap AM set. Not perfect, but it's not ruined like the head of that one. Any fit for the bin. Just make sure they're as tight as is sensible. (1987). Right, back onto power. And this time we'll put it on our roof aerial. Making sure I recover the adapter off the test gear. Good grief, he's off frequency. One on a Roger. Right, we'll leave it at that and do the on-the-air test later on today. So I've got another one of these. I have ordered some plugs and things. I'm going to make up an N-type lead to go into our test set to do these, just so we can give more accurate readings. A bit more accurate. It's still not going to be spot on because of the rod antenna and the loading coil. But I don't like the lossiness. And it will perform better on the on-the-air test, but it's still not ideal. And it's something I've never done, and I've been doing this for 40 years. But I think it's time we do, just as part of the demonstration. So hopefully by the time I do, well, I'll make sure that I've got all these parts in place and I've made up an N-type to BNC lead for the next one we do. So thanks for watching. Realistic TRC1007 from 1987. Not as long as a rod antenna as you had on the 1001 and 1005, and nothing like the range. But I think we've done a field test on these before, and if we haven't, well, we can do it with the one which I'm going to do, which I own.